March 15, 1944. Debden Airfield, England. Technical Sergeant Malcolm Reid crouched beside the wing of a battered P-51B Mustang, his hands trembling slightly as he examined what should have been impossible. The aircraft had just returned from a bomber escort mission over Berlin, its pilot reporting something that defied every engineering principle Reid understood about high-altitude flight. The Mustang had not only matched the climb rate of attacking Messerschmitt Bf 109 at 32,000 feet, it had outclimbed them. At an altitude where German fighters traditionally held every advantage, where the thin air choked American engines and left Allied pilots gasping for power, this particular P-51 had somehow found performance that existed nowhere in Republic Aviation's specifications. Reid ran his fingers along the wing's leading edge, searching for modifications, unauthorized changes, anything that might explain the impossible. What he discovered would revolutionize American fighter tactics, transform the balance of air superiority over Europe, and prove that sometimes the most profound innovations come not laboratories from engineering or corporate design teams, but from the desperate ingenuity of one mechanic working alone in a freezing hangar at 3 in the morning. The solution that would make American Mustangs faster than German fighters at altitude had been hiding in plain sight, waiting for someone creative enough to see beyond conventional wisdom and desperate enough to try the unthinkable. To understand the magnitude of what Reid discovered, you must first understand the crisis facing American fighter pilots in early 1944. The P-51B Mustang had arrived in Europe with tremendous promise, boasting range that no other Allied fighter could match and firepower sufficient to destroy any German aircraft. But range and armament meant nothing if the aircraft could not perform at the altitudes where combat actually occurred. German fighters, particularly the Bf 109G and the newer Focke-Wulf 190D variants, held decisive advantages above 28,000 feet, where the air became so thin that American engines struggled to maintain power. The mathematics of high-altitude combat were brutally simple and consistently favored German designs. The Daimler-Benz DB605 engine, powering the Bf 109G, featured a sophisticated 2-stage supercharger system that maintained excellent power output, even in the stratosphere. The BMW 801D radial in later Focke-Wulf variants incorporated methanol water injection that provided emergency power boosts at critical altitudes. Both German engines had been designed specifically for high-altitude operations, reflecting Luftwaffe doctrine that recognized altitude as the ultimate tactical advantage in aerial warfare. American engines told a different story. The Packard 5 1650 Merlin, powering the P-51B, was essentially a license-built version of the Rolls-Royce Merlin, an engine designed for different operational requirements in the early war period. While the Merlin excelled at medium altitudes, its single-stage 2-speed supercharger began losing effectiveness above 26,000 feet. Power output dropped precipitously as altitude increased, leaving American pilots at a severe disadvantage when German fighters chose to fight in their preferred environment. Combat reports from January and February 1944 painted a grim picture of American vulnerability at altitude. Major Don Gentile of the 336th Fighter Squadron reported typical encounters where German fighters would climb above 30,000 feet, then dive with overwhelming speed advantage that American pilots could not match. Lieutenant Colonel Don Blakesley, commanding the 4th Fighter Group, noted in his combat summary that P-51s caught below 28,000 feet by German fighters faced almost certain destruction unless they could dive away immediately. The tactical implications created an impossible situation for American bomber escorts. B-17 Flying Fortresses and B-24 Liberators flew their missions at altitudes between 22 and 26,000 feet, altitudes where both American and German fighters could operate effectively. But German tactics called for climbing well above the bomber formations, then diving with energy advantage that allowed them to strike and escape before escort fighters could respond. American pilots found themselves perpetually at a disadvantage, unable to climb high enough to prevent German attacks, and unable to pursue effectively when those attacks came. Staff Sergeant Malcolm Reid had been maintaining P-51 Mustangs since the aircraft first arrived at Debden in late 1943. A former automotive mechanic from Detroit who had enlisted after Pearl Harbor, Reid brought practical problem-solving skills that often frustrated his engineering-trained superiors. Where others saw specifications and limitations, Reid saw mechanical puzzles waiting for creative solutions. He had already gained unofficial recognition among pilots for modifications that improved reliability and performance within acceptable parameters. But the altitude problem seemed beyond any field modification. Engine supercharging was complex technology requiring precise engineering and expensive components. The Packard Merlin's supercharger system had been designed by some of the world's best aeronautical engineers using the most advanced technology available. If Packard's engineers could not solve the high-altitude power problem, what could one mechanic accomplish with basic tools and salvaged parts? The answer came during a routine maintenance inspection on the morning of March 12, 1944. Reid was examining a P-51B that had suffered engine damage during a mission over Hamburg when he noticed something unusual about the supercharger intake system. A piece of fabric tape, probably applied during earlier repairs, had partially blocked one of the intake ducts. The tape should have reduced engine performance by restricting airflow to the supercharger. Instead, the pilot had reported that this particular aircraft seemed to climb better than usual during the mission. Reid's automotive background provided insight that aeronautical engineers might have missed. In automotive applications, he had learned that intake tract modifications could dramatically affect engine performance, sometimes in counterintuitive ways. Restricting intake flow at certain points could actually increase velocity and improve supercharger efficiency under specific conditions. The principles were well understood in automotive racing, where intake modifications were common methods of extracting additional power from engines. The fabric tape on the damaged P-51 had created an accidental venturi effect in the supercharger intake system. By partially restricting airflow at a critical point, the tape had increased air velocity entering the supercharger impeller. Higher velocity air improved supercharger efficiency, particularly at high altitudes where air density was naturally low. The modification had essentially created a more effective supercharger system, using nothing more than a piece of fabric tape positioned at exactly the right location. Reid spent the next 48 hours testing his theory in secret, working during off-duty hours to avoid attracting attention from engineering officers who might shut down unauthorized modifications. He carefully measured intake tract dimensions on multiple aircraft, calculating optimal restriction points based on supercharger specifications and airflow dynamics. The mathematics were complex, but the concept was elegantly simple. By creating controlled restrictions at precise locations in the intake system, he could increase air velocity and improve supercharger performance across a range of altitudes. The first test installation was crude but effective. Reid used aircraft fabric tape, the same material used for minor structural repairs, to create carefully calculated restrictions in the supercharger intake ducts of Lieutenant Robert Johnson's P-51B. The modifications were virtually invisible from the outside, appearing to be routine maintenance patches rather than performance enhancements. Johnson, who had agreed to participate in the unofficial testing, would evaluate the aircraft's performance during the next combat mission without revealing the modifications to other pilots or ground personnel. On March 15th, Johnson's modified P-51B joined a bomber escort mission to Berlin, flying in formation with 11 unmodified Mustangs from the 61st Fighter Squadron. The mission would provide the perfect test environment, with German fighters certain to attack from high altitude using their traditional tactical advantages. If Reid's modifications worked, Johnson's aircraft would demonstrate improved performance at precisely the altitudes where American fighters needed help most desperately. The test results exceeded every expectation Reid had dared to hope for. When Bf-10-9s attacked from 32,000 feet, Johnson's modified P-51B not only climbed to meet them, but actually outclimbed the German fighters in the thin air, where Mustangs had never before held any advantage. The fabric tape modifications had transformed the aircraft's high-altitude performance, providing power increases that conventional engineering approaches had been unable to achieve. The engagement over Berlin lasted 17 minutes and shattered every assumption American pilots held about high-altitude combat capabilities. Johnson's modified P-51B climbed through 35,000 feet while pursuing a formation of BF-109Gs that had expected to hold absolute altitude superiority. The German pilots, veterans of the Russian front, who understood air combat as well as any aviators in the world, found themselves being overtaken by an American fighter at an altitude where such performance should have been impossible. Hauptmann Klaus Meech, leading the German formation in his Bf-109G6, watched in disbelief as the lone Mustang closed the distance despite climbing through air so thin that his own supercharged Daimler-Benz engine was struggling to maintain power. The engagement reports filed later that day by surviving German pilots described the encounter in terms that Luftwaffe intelligence initially refused to believe. An American fighter had demonstrated climb performance at extreme altitude that exceeded German capabilities, suggesting either a completely new aircraft variant or modifications so extensive that they represented a fundamental redesign. Johnson's combat report provided the American perspective on what had occurred during those crucial minutes above the German capital. At 32,000 feet, his modified Mustang had maintained manifold pressure readings that should have been impossible with standard supercharger performance. The engine continued producing power at altitudes where unmodified P-51Bs typically experience severe power degradation. Most significantly, the aircraft's rate of climb actually improved as altitude increased, exactly the opposite of normal performance characteristics. Technical Sergeant Reid met Johnson's aircraft when it returned to Debden, his hands shaking as he examined the engine cowling for signs of stress or damage. The modifications had subjected the Packard Merlin to operating conditions well beyond design specifications, and Reid had no way of predicting how the engine would respond to sustained high-altitude operations. What he found was an engine that showed no signs of abnormal wear or stress, despite performing at levels that conventional wisdom said were impossible. The fabric tape remained exactly where Reid had positioned it 3 days earlier, still creating the controlled restrictions that had transformed the supercharger's efficiency characteristics. The modification had not only survived combat conditions, but had operated flawlessly throughout the engagement. More importantly, the engine's internal components showed no signs of the stress damage that typically resulted from overboosting or exceeding safe operating parameters. Word of the successful test spread quickly through the maintenance personnel at Debden, though Reid insisted on absolute secrecy until he could understand exactly why the modifications worked so effectively. The last thing he wanted was for other mechanics to attempt similar modifications without understanding the precise mathematics involved. Incorrectly positioned restrictions could destroy engines, and Reid knew that unauthorized modifications that resulted in aircraft losses would end his military career and possibly result in court-martial proceedings. Over the following week, Reid conducted systematic testing to determine the optimal configuration for different aircraft and mission profiles. Each P-51B had slightly different intake characteristics due to manufacturing tolerances and wear patterns, requiring individual calibration of the restriction positions. Reid developed measurement techniques using improvised tools that allowed him to calculate the correct modification points for each aircraft within acceptable margins of error. The testing revealed that the fabric tape modifications were most effective at altitudes above 28,000 feet, exactly where American fighters needed improved performance most desperately. Below that altitude, the modifications provided minimal benefit and in some cases actually reduced power output slightly. But 1,000 above 30 feet, the performance gains were dramatic, typically increasing manifold pressure by 12 to 15% and improving rate of climb by nearly 20%. Lieutenant Colonel Don Blakesley, commanding the 4th Fighter Group, finally learned about Reid's modifications on March 22nd, when Johnson could no longer keep the secret from his squadron commander. Johnson's consistent ability to outperform other P-51Bs during high-altitude engagements had attracted attention from pilots who knew their aircraft intimately and recognized performance characteristics that didn't match standard specifications. Blakesley's initial reaction was exactly what Reid had feared. The colonel was furious that unauthorized modifications had been performed without engineering approval and demanded to know what other aircraft had been similarly modified. Reid admitted that he had tested the modifications on 3 additional aircraft, all with similar performance improvements, but insisted that the modifications were both safe and effective based on his extensive testing. The confrontation in Blakesley's office on the evening of March 22nd would determine whether Reid's innovations would be adopted throughout American fighter units or suppressed as dangerous, unauthorized modifications. Blakesley had built his reputation on strict adherence to regulations and proper procedures, but he also understood that the war would be won or lost based on practical results rather than bureaucratic compliance. Reid's presentation to his commanding officer relied on data rather than theoretical explanations. He had documented performance improvements across multiple aircraft and flight conditions, demonstrating that the modifications consistently provided significant advantages at critical altitudes. More importantly, he had engine inspection data proving that the modifications did not cause mechanical stress or reduce engine reliability. The engineering principles underlying Reid's discovery were actually well established in automotive applications, though aeronautical engineers had not applied them to aircraft supercharger systems. The Venturi effect created by controlled restrictions could increase air velocity and improve supercharger efficiency, particularly at high altitudes where natural air density was reduced. Reid's innovation was not in discovering new physics, but in applying existing principles to solve a specific problem that conventional approaches had failed to address. Blakesley agreed to authorize continued testing under controlled conditions, but insisted that any further modifications be documented and monitored by engineering personnel. Reid would be allowed to modify additional aircraft, but only with proper oversight and systematic evaluation of results. If the modifications proved consistently effective without compromising safety, Blakesley would forward recommendations to higher headquarters for possible adoption throughout the 8th Air Force. The expanded testing program began immediately, with 6 additional P-51Bs receiving Reid's modifications under carefully controlled conditions. Each aircraft was extensively tested both on the ground and in flight, with detailed measurements of engine performance, structural stress, and overall flight characteristics. The results confirmed Reid's earlier findings while providing the documentation necessary for official approval of the modifications. By early April 1944, the 4th Fighter Group was operating nearly 20 P-51Bs with Reid's fabric tape modifications, all showing consistent performance improvements at high altitude. The modifications had proven so effective that German pilots began reporting encounters with American fighters that demonstrated capabilities significantly beyond standard P-51 performance parameters. Luftwaffe intelligence struggled to explain how American aircraft were suddenly able to compete effectively at altitudes where German fighters had previously held decisive advantages. The tactical implications began manifesting immediately in combat results. American pilots found themselves able to climb with German fighters rather than being relegated to defensive tactics at high altitude. Bomber escort missions became more effective as P-51s could position themselves above attacking German fighters rather than being forced to react to attacks from superior altitude positions. The psychological impact on German pilots was equally significant as they lost the altitude sanctuary that had been fundamental to Luftwaffe tactical doctrine. Major General William Kepner, commanding the 8th Fighter Command, received Blakesley's formal report on Reid's modifications on April 8, 1944. The report included detailed performance data from over 40 combat missions, engine inspection records from modified aircraft, and tactical assessments from squadron commanders who had observed the improvements firsthand. Kepner, a pragmatic leader who valued results over regulations, immediately authorized expanded testing across multiple fighter groups. The authorization came with strict conditions. Reid would be temporarily assigned to 8th Fighter Command headquarters to oversee implementation of his modifications across the 8th Air Force. Each modification would be documented with precise measurements and installation procedures. Most importantly, Reid would train selected maintenance personnel at each base to ensure consistent application of the technique without compromising safety or effectiveness. Reid's first assignment under the new authorization was to visit the 355th Fighter Group at Steeple Morden, where pilots had been reporting consistent losses during high-altitude engagements with German fighters. The group's commanding officer, Colonel Claiborne Kinnard, had specifically requested assistance after losing 6 P-51Bs in a single week to German fighters attacking from above 30,000 feet. The journey from Debden to Steeple Morden on April 12th gave Reid his first glimpse of how his simple modification might affect the entire course of the air war over Europe. Intelligence reports indicated that German fighter tactics were becoming increasingly dependent on altitude advantage as Luftwaffe pilot quality declined and fuel shortages limited training time. If American fighters could neutralize that altitude advantage, German defensive capabilities would be severely compromised. At Steeple Morden, Reid encountered skepticism from maintenance personnel who had seen numerous unauthorized modifications fail catastrophically. Chief Master Sergeant Robert Hayes, responsible for maintaining the group's 52 P-51Bs, initially refused to allow any modifications without written approval from Packard Motor Company's engineering department. Hayes had witnessed engine failures caused by well-intentioned but poorly executed field modifications, and he was unwilling to risk aircraft and pilot lives on untested theories. Reid's response demonstrated the practical approach that had made his discovery possible. Instead of arguing theory, he requested permission to modify a single aircraft that was already scheduled for engine replacement due to excessive wear. If the modification caused engine failure, the aircraft would simply receive its planned engine change slightly ahead of schedule. If the modification worked as advertised, Hayes would have concrete evidence of its effectiveness. The test aircraft selected was a war-weary P-51B that had completed over 100 combat missions and was showing signs of engine deterioration that made it unsuitable for combat operations. The aircraft served as a perfect test platform because any engine problems could be attributed to existing wear rather than Reid's modifications. Hayes agreed to the test under conditions that limited risk while providing meaningful performance data. Reid spent 18 hours carefully measuring and modifying the aircraft's supercharger intake system, using techniques he had refined through months of experimentation at Debden. The process required removing engine cowling panels to access intake ducting, precisely calculating restriction points based on supercharger specifications, and applying fabric tape with mathematical precision that would have impressed aeronautical engineers. The installation process revealed the elegant simplicity underlying Reid's innovation. Each piece of fabric tape was positioned to create a controlled restriction that increased air velocity at a specific point in the intake system. The restrictions were small enough to avoid causing significant pressure drops that would reduce overall airflow, but large enough to create velocity increases that improved supercharger efficiency at high altitude. Flight testing began on April 15th, with Lieutenant Colonel Jack Bradley, the group's operations officer, conducting systematic evaluation of the modified aircraft's performance characteristics. Bradley was an experienced test pilot who understood both the aircraft's normal capabilities and the performance requirements for effective high-altitude combat. His assessment would determine whether Reid's modifications justified the risks inherent in any unauthorized changes to critical aircraft systems. The initial flight tests confirmed every performance improvement Reid had documented at Debden. At 30,000 feet, the modified P-51B maintained manifold pressure readings 15% higher than identical unmodified aircraft. Rate of climb above 28,000 feet improved by nearly 25%. Most significantly, the aircraft continued climbing effectively to altitudes where standard P-51Bs typically reach their operational ceiling. Bradley's detailed flight test report provided the technical validation Hayes needed to authorize widespread implementation of Reid's modifications throughout the 355th Fighter Group. The report documented performance improvements across all relevant parameters, while confirming that the modifications did not compromise engine reliability or structural integrity. Hayes immediately assigned 4 experienced mechanics to work with Reid in modifying additional aircraft. The modification process at Steeple Morden revealed logistical challenges that would affect implementation throughout the 8th Air Force. Each aircraft required individual calibration based on its specific intake characteristics and engine condition. The process typically required 6 to 8 hours of skilled labor per aircraft, time that had to be scheduled around normal maintenance requirements and operational missions. More significantly, the modifications required fabric tape that met specific strength and adhesion requirements. Standard aircraft fabric tape worked effectively, but supplies were limited and allocated for structural repairs rather than performance modifications. Reid calculated that modifying all P-51Bs in the 8th Air Force would require approximately 12,000 yards of suitable tape, quantities that would need to be requisitioned through normal supply channels or obtained through informal arrangements between maintenance units. By April 20th, the 355th Fighter Group had 23 modified P-51Bs in operational service, all showing consistent performance improvements during high-altitude missions. Pilot reports indicated that German fighters were no longer able to attack bomber formations from altitude sanctuary, forcing them to engage at altitudes where American fighters could compete effectively. The tactical balance over European skies was shifting in favor of Allied forces. The success at Steeple Morden attracted attention from other fighter groups whose commanders had heard unofficial reports about modified P-51Bs outperforming German fighters at extreme altitude. Colonel Hubert Zemke, commanding the 56th Fighter Group at Boxted, personally requested that Reid visit his unit to evaluate whether similar modifications would be effective on their aircraft. Zemke's request presented Reid with a new challenge. The 56th Fighter Group operated P-47 Thunderbolts rather than P-51 Mustangs, and Reid had no experience with the radial engine and turbocharger system that powered the Republic fighter. The Thunderbolt's supercharging system was fundamentally different from the Merlin's centrifugal supercharger, raising questions about whether Reid's modification principles could be adapted to different engine configurations. Reid's visit to Boxted on April 25th began with intensive study of P-47 engine systems and supercharger characteristics. The Thunderbolt's turbocharger system was more complex than the Merlin's mechanical supercharger, but the basic principles of airflow dynamics remained consistent. Reid believed that controlled restrictions at appropriate points in the intake system might provide similar performance benefits, though the optimal locations and restriction sizes would require extensive testing to determine. The P-47 modification project required collaboration with Technical Sergeant Frank Morrison, the 56th Fighter Group's most experienced engine specialist. Morrison had maintained P-47s since the aircraft first entered service and understood the turbocharger system's operational characteristics better than anyone else at Boxted. His expertise would be essential for identifying modification points that would improve performance without compromising the complex turbocharger system. Morrison's initial assessment was cautiously optimistic. The P-47's turbocharger system included multiple intake paths and intercooler systems that might benefit from controlled airflow modifications. However, the system's complexity also created more opportunities for modifications to cause unintended consequences that could result in engine failure or reduced performance under certain conditions. The collaborative approach between Reid and Morrison produced modification techniques specifically adapted to P-47 characteristics. Instead of fabric tape applied to intake ducts, the P-47 modifications involved carefully positioned restrictions in the turbocharger's wastegate system and intercooler ducting. The modifications were more complex than Reid's original P-51 technique, but they addressed the specific characteristics of the turbocharger system. Flight testing of the modified P-47 began on May 2nd with Major Robert Johnson, an experienced pilot who had flown both standard and modified P-51Bs and could provide comparative assessments of performance improvements. Johnson's evaluation would determine whether Reid's principles could be successfully adapted to different aircraft types and engine configurations. The P-47 test results were encouraging, but less dramatic than the improvements achieved with -51Bs. The modified Thunderbolt showed approximately 8% improvement in high-altitude performance, significant but not as substantial as the 15 to 20% gains typical with modified Mustangs. The difference reflected the P-47's already superior high-altitude capabilities and the greater complexity of modifying turbocharger systems compared to mechanical superchargers. Despite smaller percentage improvements, the modified P-47s provided tactical advantages that complemented the enhanced P-51B capabilities. Thunderbolts equipped with Reid's modifications could climb with German fighters at altitudes approaching 40,000 feet, altitudes where even modified P-51Bs began experiencing performance limitations. The combination of modified P-51Bs and P-47s created overlapping altitude coverage that eliminated German altitude sanctuary across the entire operational envelope. By mid-May 1944, Reid's modifications were being implemented across 6 fighter groups in the 8th Air Force, with nearly 200 modified aircraft in operational service. The widespread adoption required Reid to train dozens of maintenance personnel in proper modification techniques while developing standardized procedures that ensured consistent results across different bases and maintenance units. The training program revealed the depth of technical knowledge required for successful implementation of Reid's seemingly simple modifications. Each mechanic needed to understand supercharger theory, airflow dynamics, and precise measurement techniques that determined optimal restriction placement. The modifications appeared simple, but required expertise that combined theoretical knowledge with practical mechanical skills. Technical Sergeant Malcolm Reid's fabric tape discovery fundamentally altered the balance of aerial warfare over Europe in the spring of 1944. What began as an accidental observation during routine maintenance evolved into a systematic modification program that eliminated German altitude superiority and transformed American fighter tactics across the entire theater. Reid's innovation proved that the most revolutionary advances often emerge not from corporate research laboratories or government engineering programs, but from the practical ingenuity of individuals who see solutions where others see only limitations. The mathematics of Reid's success were elegantly simple. By understanding basic principles of airflow dynamics and applying them with precision born of automotive experience, he had solved a problem that had confounded aeronautical engineers for months. The fabric tape modifications cost virtually nothing to implement, required no rare materials or specialized tools, and could be applied by any competent mechanic with proper training. Yet they provided performance improvements that conventional engineering approaches had failed to achieve despite massive investments in research and development. By war's end, thousands of American fighters carried Reid's modifications, their pilots no longer forced to concede altitude advantage to German opposition. The tactical revolution that began with a single piece of fabric tape had spread throughout Allied air forces, proving that innovation requires not complex technology or unlimited resources, but simply the willingness to look beyond conventional wisdom and try something that everyone else considers impossible.